Chapter 8, we're going to wrap up just the end of the material that'll be on the exam in a week. 8.3, testing claim about a mean. So what's the difference between what we did last time and what we're going to do this time? Do you understand what these two things are talking about and what they mean is the difference?
Percentage. Proportion to.
Yeah, percentage was last time, averages are this time. Exactly. So same kind of stuff, can be very similar, null, alternative, all that kind of stuff's the same. It's just going to be about averages instead of percentages. So probably be fairly easy for you, I'm thinking, because it's not a lot different. All right, so testing claims about a population. Mean with sigma not known requirements. The sample is a simple random sample, either or both conditions. Remember how we talked about you got to have a normally distributed population or the number in your sample's got to be greater than 30. So that's the same thing as before. So requirement of normality or n greater than 30. If the original population is not itself normally distributed, then you got to have the greater than 30. Sample sizes 15 to 30 are good enough if it's not far from normal. And n greater than 30 is justification. Sample means normal distribution, regardless of how far it departs. So that is good enough. But we don't go into a lot of those details. So the basic rule, so I feel like I just waved my hands over that, I pretty much do. But basically, you got to have either a normal population or n greater than 30, because everything's got to be on a bell curve, doesn't it? If the original data is not in a bell curve, as long as you're talking about taking more than 30 at a time, that'll make it bell curved. I hope that makes some good sense to you. Anyway, there's not a lot you're going to need to do with that. Let's look at an example. The author obtained times of sleep for randomly selected adult subjects, including in the National Health and Nutrition Examination Study. And those times in hours are listed below. Here are the unrounded statistics for this sample. So n equals 12. X bar, what's X bar? See the X bar there? What does that mean when we put a bar over X like that? Average. That means mean. That means average. So that's average number of hours of sleep. How many hours do you sleep a night?
4.
Okay, I know some of you aren't doing a lot of sleeping. 6.8 with a bunch of 3s. I'm getting a little older, and I enjoy a nice nap around the middle of the day, whenever I can, and a good 7 hours every night on top of it. I like to sleep. Maybe I'm lazy. But anyway, so S, there's the standard deviation. Common recommendation is that adults should sleep between 7 and 9 hours. Wow. Anybody get over 8? That's all right. 7 and 9 hours each night. Use the p-value method with 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours. So we have there's a bunch of hours people slept. 4, 8, 4, 4, blah, 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 blah. So the question is, test the claim that the mean amount of sleep for adults is less, for those adults, is less, well, for all adults, is less than 7 hours. All right, so how are we going to do it? Is it a simple random sample? Yeah, they said it was simple random. Somewhere. I don't know where. There it is. Randomly selected adults. So they grabbed adults at random, 12 of them, right, 12? Yeah, 12 adults at random, and they found the average number of hours they slept is 6.833. There's the standard deviation. And the sample size is n equals 12. Now that's not more than 30. Is it okay to use a sample size that's not more than 30? Under what circumstances?
They're normally distributed?
Yeah, if it's normally distributed. Right, exactly, Ken. Yeah, back over here. And they said it was, I think, somewhere. I don't know where. Didn't they? Maybe. I don't know. I'm going to move on. They had to be normally distributed. Did it say it somewhere? So we must determine whether it's, okay. My mistake. They're going to determine whether it's normally distributed or not. How do you take a bunch of numbers like these, and find out if that comes from a normally distributed population or not.
The plot.
Yeah, remember the plot stuff we did? Where you put it, now we're not going to redo that, but they're going to do it. They remember this kind of thing where you put it on, what's the thing called? The quantile plot. Remember we did a little bit of that one night? So they're basically doing that here, and they're saying, hey, look, the data is all kind of in a line, right? It's in a straight line, sort of. And then here's the other plot, which looks kind of like a bell, a little bit, I guess. It's sort of, high in the middle, a little bit lower on the side. So they're saying, all right, looks pretty good. That's a normal quantile plot and a histogram. Both are approximately normal, kind of bell-shaped, so good enough. Again, we're not going to have to go through all this detail. But I do want you to know the whole story. This is the deeper story if you ever actually do a study like this, officially. So the claim is that the adult sleep is less than 7 hours. And so that's our null. Remember, the null is always the equals. So the alternative is less. Actually, the alternative is the original claim. And the null is the equals. Nulls are always equals, right? All right, so step 4, alpha is 0.05, population mean, sample mean, find all that stuff like usual. Here's the p-value from technology. They have a whole bunch of technology there. There's the p-value. So what does that p-value mean? 0.3887.
3%.
Yeah, 38%.
Higher.
38% what? What does that mean? It's 38.87% of what? What is a p-value?
Luck.
Yeah, something about luck, huh?
Probability.
Probability? Yeah, probability of luck. What's luck? Yeah, good. It's the probability that the sample results were just lucky. That they just came out, whatever they came out, high, low, whatever, and that it was just lucky. That they just, that you just happened to get a few adults that were longer sleepers or shorter sleepers or whatever. Something kind of weird happened that it wasn't really representative of the truth. Does that make sense? It was just kind of lucky results. That's what p-value means. Probability of luck. Probability of luck. So, what does that mean about our conclusion? Is that a high probability or low, or what's the deal with that?
I think yes.
Yes, what?
It's not. It's a high probability that it's luck.
It's over 5%.
Is it compared to significance level?
Yeah, so what I mean, which one are we going to go with, HO or H1 based on that p-value?
H1.
So what was our saying? Maybe I should write that up again. When p is low, if p is low, is that how we said it? If p is low, HO must go. So, now what do we mean by low? Yeah, usually less than 0.05, huh? Or whatever they give us. Usually 0.05. So is that low? No. So we're keeping HO, aren't we? HO's not going to go, we're going to keep it. Right? If the P is low, meaning lower than 5%, the HO must go. The HO must go. But that P was not low, so the HO will not go. We keep the HO. So what was the HO? So p-value is greater, so it's not low. So we fail to reject the null. We don't reject the null. We're keeping the null. And what was the null? I already forgot. I don't know. What was the null? HO, equals 7. So it was mu equals 7. And this was mu, what was it? Less than 7. Less than 7. And the claim was there, it was less than 7. So we're keeping HO. We're keeping HO. Does that mean there's strong evidence or weak evidence? Whenever you keep HO? So weak, it means weak evidence. Whenever you keep, remember, because that's the assumption like a court of law. Remember, HO is the assumption like a court of law. You assume innocence, right? You assume HO. We assume HO is true unless strong evidence moves us to H1.
So is this where we use the insufficient stuff?
Right, because if it's weak evidence, it's not sufficient, is it? Exactly, well said. That's kind of like what Mai was bringing up as well. Exactly. That's the truth. So if there's weak evidence, then there's not enough evidence, is there? There's insufficient. We fail to reject the null. We conclude that there's not sufficient evidence to support the claim. We don't support the claim that the amount of sleep is less than 7 hours. Does that seem weird? What was the average? Let's go back again. We had 12 adults. They randomly sampled these 12 adults, and the average came out 6.833. Let me bring it over here. So the average from 12 adults, so they randomly grabbed 12 adults, and the average was 6.83 hours of sleep per night. And the claim was less than 7. Doesn't that seem like less than 7? So why aren't we accepting the claim?
Too close to the false.
Because the p-value?
Yeah, what about, and the p-value came out. Oh, right there, yeah.
Because it's great. It's 1.8.
So if you were doing this claim, read this claim, you read a paper in your job, and they had this test, and they got this p-value, and so what if you were look at these results and somebody said, hey, the average came out under 7, right? 6.8. That's under 7. Average came out under 7, which was the claim. The claim was, the average adult sleeps less than 7. The average for 12 people saying at random was under 7, 6.83. And yet we're staying with HO. We're not going with the claim.
We're rounding up?
It's not a rounding issue.
Standard deviate that 1.89, plus or minus what on the slide before.
Right, standard deviation.
Yeah, it was 1.89 or 98. So
What does the p-value have to do with our conclusion? Is this making sense? What's the p-value have to do with our conclusion?
It's not higher than 0.5?
Yeah. So what does that mean? Real life. Like why? I want you to be as real as we can with this. Stats is real life. Why, real life, are we not accepting this claim? Right. That was the conclusion here. Right. Because we failed to reject the null, we concluded there's not sufficient evidence.
Because there's only 12 adults that were tested, and there wasn't enough evidence or enough people to actually create a concrete evidence that it's 6.3.
Yeah, that's pretty well said. I would add to that.
Well, it's a chance of luck with 12 people too.
Right, part of it. But 12 people could have been enough if we would have got a number super far from 7. So it's not just that they weren't enough people. That's part of it. But it's also that there weren't many people and it came out pretty close to 7. You know what I mean? So if you're only doing 12 people and it comes out pretty close to 7, that could easily have just been a lucky draw and really the average is over 7. It's just pretty, in fact, there's a 38% chance of that. That this was just a lucky 12 people that barely came out under 7, and in reality, the real average for all adults, that's what we're trying to determine here, right? You're always trying to get to the real deal. The real average for all adults might be greater than 7, and we just happen to get a lucky 12 adults. Like Ken says, 12 isn't very many, but you also want to add to that, if we grabbed 12 adults and the average had come out something like 4.3, well, then we'd believe it, because that's so low, there's no chance, really, not a very reasonable chance, that the average could be over 7 if the 12 we grabbed at random had such a low thing as 4 point something. But it didn't. It came out pretty close to 7, didn't it? Pretty close to 7, and it was only 12 adults. So we would say there's just not strong enough evidence. Yes, there is some evidence. Granted, this group came out under 7. There's some evidence, but there's not strong. It's like the court of law where they bring in evidence that the person did the crime, but it's just not really strong. Just not really strong. There's weaknesses in it, and you don't want to conclude something without strong evidence. That's what we're saying. There is definitely some evidence, but it's not strong. There's too big a chance it could just be lucky. Could have been a lucky sample, because it was only 12 people and it came out pretty close. That making sense? Getting the idea behind these numbers and what they mean in real life? So it's the same thing we were doing before, and that's it for that. All right, question number 1 then. So let's do some homework. So they're going to start on these first 2 or 3 questions. They're just going to give us the output from the computer, from the calculator. So they just want us to deal with the words and the meanings of things. So the display provided, there's the answer from technology. So what do they want us to test here? They want us to test that smartphone, display provided technology, blah, blah, using data for a smartphone carrier's data speeds at airports to test the claim that they are from a population having a mean less than 4. So a mean less than 4. So that's the claim. So let's write that up. Remember how we always start with that? So the claim is, now we're dealing with that. That's the Greek M. Remember how we talked about that symbol? That's a funny looking Greek M. It's called mu. They're saying the mean less than 4. That's the claim. So can you figure out which of those is the right HOH1? Yeah, it's got to be A, huh? We good with that? It's got to be A there, because the HO is always the equals. So, and the claim has got to be the HO. I'm sorry, it's got to be the H1. So the HO is always equals, and the H1 is the less than. That makes sense? All right. So can you go ahead and draw a conclusion on that. Let me give you a second. Rather than me just whip it out, give that one a thought. So the test statistic is the t value. So there it is right there. It is negative, what is that? I can't even read it. Negative 0.17. What are they, 2 places? Negative 0.17. We're not even using those. But it's the t value, negative 0.17. The p value is 0.4. They want 3 places, right? 0.432. If you can read that, it's kind of small there. 0.432. What's that?
You have to click on that.
Oh, shit, what?
Yeah, it says the T and the P.
All right. So now, how are we going to? Oh yeah. It wants you to click on something, doesn't it, on the screen? It has some kind of icon that you click on.
Is that always going to be available like that? Like a little box?
No, it's just for these first 3. They're just getting us warmed up. We'll do it on our own calculator in a minute. They're just getting us warmed up. No, it'll be just like last time.
I was like, this is easy.
All right. So from that, can you go ahead and state a conclusion? Let me give you a second. So what's the p-value? The p-value is 0.432. Is that a low p-value or not? No. So remember the saying, if the p is low, HO must go. But the p is not low.
So you failed to reject.
So p is not low. Let me change the thing here. P is not low. So we keep HO. HO doesn't go. We keep HO.
Failed to reject.
Yeah, right? So I'm keeping HO. Keeping HO. Everybody with me so far? Right? If the P is low, as is on the board, but that's the thing you want to know. If the P was low, it's not low. But if it is low, then HO must go. Meaning it's go away. Is what we mean by that. It must be crossed off. But it's not low, so the HO is not going to go. It's going to be kept. So we're keeping HO. And by the way, which one of these is the claim? HO or H1? It can be in either place.
H1.
Yeah, you can tell H1 the claim right there. This must be the claim. Okay, so good so far. So we're keeping HO. because P is not low. Now, what does that mean about weak evidence, strong evidence? That's why I wrote this on the board. Whenever you're keeping HO, that is always weak evidence, not strong. And whenever you're doing H1, that's strong. Remember, that's like the court of law. Why am I saying that? Because we assume HO. Do you get how this test works? It's just like the court of law. What do they do in a court of law? They assume innocent. What does that mean that they assume innocent? Meaning if evidence is not super strong, they're going to stick with innocent. Right? So whenever a person gets an innocent verdict, that means evidence was not strong. And whenever they get a guilty verdict, that means evidence, at least in the jury's opinion, was strong. Right? So that's what I mean by HO is always weak, because that's what you assume. Whether that's the claim or not. You realize the claim can be on either one. That comes later. Don't worry about the claim right now. Just get super clear on what HO and H1 mean, and then you'll be able to say whatever about the claim, depending on where the claim is. But just focus on HO, H1 first. So if you're going with HO, that means there was weak evidence, not strong, not sufficient, not enough to get you to reject HO. You're staying with your original assumption, like in a court of law with innocence. HO is always innocent, initial assumption. H1, you're only going with H1 if evidence was strong, because you assumed HO was true until you saw strong evidence to move you to H1. Okay, so that means in this case, we're staying with the original assumption HO, which means evidence was weak, and we're not taking the claim. The claim was the other one, notice. So evidence was weak. All right, so what does that mean then? What are we doing with HO? Yeah, fail to reject, FTR, right? Fail, we don't reject it, we keep it. We're keeping HO, aren't we? And is there strong evidence or weak? There's not, it's insufficient. I think that's the word they want. Or not sufficient, is that what they want? I forget their specific wording. Not sufficient evidence to support the claim. How are we doing? Is that making sense?
That's what I'm saying.
Is that a clarifying question?
No, he went on the next one.
Oh, different one. Next one. Yeah, we'll get there. Is that good there then? So keeping all those words together and what they mean? All right, let's try another one. So number 2. Park officials make predictions of times to the next eruption of a particular geyser and collect data from the errors, minutes, in those predictions. The display from technology available, blah, blah, blah. What are we testing the claim of? Test the claim. So that's the main thing you need. Yeah, let me let you do it. Here's the claim. Test the claim. There it is. Where is it? The mean, there's the claim. So claim, let me write it bigger for you. Claim, mean prediction error is equal to 0. Okay, so guys and gals, can you focus up here for a second? As I'm wandering around, I'm seeing there's some confusion, and so what I want to encourage you to do is when I give you a recipe, you need to follow that recipe. I'm a pretty amazing cook. I'm kidding. I only cook 2 things. I barbecue and I make scones. And let me tell you about my first thing is the claim. And then second thing, we've got to write the HO. This will come together for you. If you're confused, follow the steps. They will lead you there. HO, H1. Now, what is HO always? Equals. Always. So, I'm going to write equals. Okay, now, what's the claim? What's being claimed here? The mean prediction error is equals. So, mu. So, write that. Actually, write that. So equal to 0. So that's equal to 0. So that is the claim, isn't it? So you want to write next to, notice what I do every time. I write next to one of these 2, which one's the claim. Have you seen that pattern? That's what I do every time. Last week, this week, the claim is either going to be the HO or the H1. It's not a mystery, right? it says right here, equals 0, so it's HO. It's got to be. And what's the H1?
Not equal to.
Yeah, when the main one's equal, the other one's not equal. That's all that's left, huh? Yeah, we don't have a greater than or less than anywhere, do we? So it's got to be not equal. All right. And so now, we good? So you got to have that down before you go and try to conclude things. If you don't have that down, it's going to mess you up when you, unless you're really comfortable and did these for years, you could just jump to it. But I notice that's troubling a lot of people. So write this down, have this clearly before your eyes, and then go to the p-value. What's the p-value? Super low, huh? The p-value, it says, is lower than, what is that? I can't even see it now. Look there. But it's super low, whatever it is. 0.0001. So it's super, super low. So now what does that mean? I've given you a statement here. If the p is low, HO must go. So P is super low, HO must go. So now that means what do I do every time? I go back to my HOH1 and I cross one of them out and circle the other one. It's like a judgment, right? The jury brings forth the verdict. So if the P is low, it is. HO must go. We mean out of there, HO. You're gonzo, right? So HO is out, and H1 is what we're going to keep. So I haven't said anything about the claim yet, notice. I'm just getting really clear HO, H1. Does that make sense? And now, let's do the strong evidence, weak evidence thing. What is always true about strong evidence, weak evidence?
H1 is strong evidence.
Yeah, HO's weak, H1's strong. Every time. If you're ending up with HO, that was weak. If you're ending up with H1, that was strong. Whether it's the claim or not. Just the fact that if you go with HO, it's because evidence was weak, because it's like a court of law, right? Innocence. There wasn't good proof to get off of innocence. Or if you're going with H1, we're going with H1. That means there must have been strong evidence, huh? Whenever you're going with H1, evidence is strong. Okay, so what can we conclude now? Now we're done. Now do you see the conclusion? There is strong evidence of what? For the claim or against the claim?
Against the claim.
Yeah, because the claim's the other side. And I went with this side. So strong evidence that the claim is wrong. Strong evidence that the claim is wrong. Strong evidence that mu does not equal 0. Do you see that? See how I just arrived there? It's just step by step by step by step. Just follow the recipe. Do you see this, what I do? So don't skip these steps, though. Unless you're super good. I never care. You can do whatever you want. But what I'm noticing is you're not yet that comfortable, and you try to skip some steps, and you get all messed up. So if you're having trouble, then go back and carefully do the, what are the steps again? I write the claim out. Then I write the HO is always the equals, and the H1, and then I write which one the claim is next to. And then I go to the p-value. If it's low, I cross off the HO, I circle which one of these I'm keeping. And then I write strong or weak evidence. Always weak for HO, always strong for H1. And then I'm able to conclude what happened. So strong evidence that the claim is wrong. Mu does not equal 0. The claim is crossed off. So then we'll translate that into, I forgot to go back here and put in the test. So the T, what was that, minus 7.37. And what was the p-value? Do they even say what it is? What do they want me to put there? 0?
Yeah, because there's only 3.
Yeah, I guess it just rounds to 0. It's like super low. They just want 0. All right, so what do we do? State the final conclusion. Are we going to reject or fail to reject HO?
Reject.
Yeah, right here, look at HO's crossed off. We reject HO. Was there strong evidence to conclude that the original claim, the main prediction, it was 0. There is, strong, sufficient. There's enough evidence, to conclude that the original claim is not correct. See how I'm saying that? See how the claim is crossed off? Because the claim was on this one, huh? And it's sufficient. Strong means sufficient.
Mr. Mayor,
Yeah.
so the claim, do you choose or do you just randomly put it?
Well, see the claim is right here. Claim mean is equal to 0, which is this one.
Oh, okay.
Yeah, it'll literally be one of these two. Yeah, does that make sense how I did that? I just took their words, test the claim that the mean is equal to 0. I just took those words and I said, oh, which one is that? Oh, that's HO. It'll always be one of those two. And then we rejected HO, so we rejected the claim, didn't we? So there is, if the mean prediction is not correct, there is, I don't know what they want there. There is, what do they want? I don't even know what they want there. We're concluding this. Mu is not equal to 0. There is, so there must be some error. There's not 0 error. So there's some error. Yeah, is that the word they have? Do they have some or none or something like that? Yeah, do you see why we're saying there's some error? Remember what mu is? Mean prediction error. And we said it's not 0. So if it's not 0,
The claim is equal to 0, and if it's opposite of 0, that means there's some in there.
yeah,
So that
the
means
claim was there's no error, 0 error,
right,
and we rejected that.
right.
So there is some
The
error.
opposite of 0 would be some.
Some. Yeah, it's not 0, so it's some. Yeah. Does that make sense? Is the recipe making sense? How I'm going through the steps there? On that? Something I can say to help with that? But just practice, I guess. Try another one. Anything I can help with on that? So again, start with the claim and literally write it down. Mu, it'll be equal, greater, less. Write that down. Write your HO, H1. HO is always equal. And then write which one's the claim. And then do the P is low and almost go thing. Make sure in the end you're circling one of these and crossing off the other. So what I'm seeing is there's confusion between the claim and the HO, H1. Remember, the claim can be on either one. So first focus on HO, H1, but put the claim next to one of them. And then, follow the HO, H1, and the claim is tagged to one of those two. All right, let's try. All right, so a data set includes data from 400 random tornadoes. The display, blah, blah, blah. Test the claim, blah, blah, blah. All right, let's try this one. Switch a little bigger. The claim, where is the claim? There it is. Test the claim. So I always just grab the claim words first up. Claim is the mean is greater than 2.4. There we go. How are we doing? Is this making good sense? All right, so there's the claim. I'm going to write HO and H1. HO is always equal, isn't it? Oh, I forgot to write what this claim is. So greater, so this is mu greater than 2.4. That's the claim. Greater. So is that going to be HO or H1?
H1.
It's got to be H1. Because the HO has got to be the equals. You tracking with me? So the HO is always equals. The null is always equals. The claim is greater, so the claim must be on H1. Good there. So now, what's the p-value? Well, they want me to put the test statistic, the t. I can't even tell what the t is. It's 1.76. So I'll put that down first. 1.76. And then, okay, what's the p-value? The p-value is 0.0394, at least mine is. 0.0394. 03. Oh, they just want three places, huh? 0.039. All right, is that a low p?
Yes.
Yeah, so the p is low. So what does that mean?
HO must go.
HO must go. So I'm going to cross off the HO. He's out of there. So that means we're sticking with H1, which also happens to be the claim. Is evidence strong or weak?
Strong.
H1, it's always strong. meaning sufficient. There's enough. All right. So we can write the rest, right? So what did we do? We rejected HO, didn't we? Reject the HO. There is sufficient, there's enough strong evidence to support the claim the tornado is greater than 2.4 miles. Yeah. Good? Is that getting easier? That making sense?
Yeah.
Till the next one.
Till the next one. All right. Starting at number 4, we're going to do our own calculations. So number 4, data set, student evaluations, of course, the summary statistics. Use a 0.01 students level test claim, population and course evaluations as the mean equal to 3.75, blah, 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 blah. All right, so what's the first thing we always write on these problems?
Claim.
The claim, exactly. So, yeah, where is it? I lost it. Oh, there it is. Test the claim that the mean is equal. Equal 3.75? All right. Okay, so HO and H1 from there. So HO, H1, HO is always equal. And that is the claim this time, huh? Notice that exactly matches the claim. So the claim this time is HO. So what am I going to put for H1?
Opposite.
Opposite? Not equal, huh? Because we don't have any greater or less anywhere on this problem, do we? They never said greater or less, did they? All right. So now it's time to hit the buttons on the calculator. So you're going to go to your calculator and hit stat, and then go over to tests. Yeah. Go over to tests and go down to t-test. It's number 2, right? T-test. T-test, that's what we're going to use for this. So you're going to want to put all these on your 3x5 card for the exam in a week. T-test. And then you'll get a screen that says input, data, or stats. You getting that? Already been there? So input are either data or stats. We want stats on this one. In a minute we're going to do data. We'll put in our own data. But for this one, choose stats, meaning we have these summary statistics right up here. Stats, and then it wants mu0, just like before. What's mu0? Where do we get mu0? See that little sub-zero?
It's your mean.
Yeah, it's your null, right? H sub-0, 3.75? Is that making sense so far? So I don't want you to get confused and put the 3.69 in too early. It's the 3, and how we know, if it has the sub-zero, we go to the sub-zero. And get the number right from there. That's just the same way we did in last night's homework, or whenever you did that. Yeah, it was P0. Yeah, we had a P0, now we have a mu0. Same thing, huh? Just grab it from the 0. Is that good? Same kind of thing. And then X bar. Well, X bar, it says it right here, huh? 3.69. And then it wants S sub X, the standard deviation. That's going to be the 0.62 on my example. N, that's the number of people in the study. They told me 90. I'm just grabbing those numbers from the top up there. Right up here. The N, the X bar, the S. And then it asks me what kind of test we're doing. It says, are you doing, what does it say? Not equal, or greater, or less or greater. We're doing a not equals. Right here, not equals, so we choose not equals. And then go down to calculate. And calculate it. And so the answers I got, well, all I care about is the p-value. I'm getting a p-value of 0. Well, they asked for a test statistic. So that'd be the t. Negative 203.6. Did you guys get that, or did I hit the wrong button?
I got negative 9.91.
Yep.
P-value is negative 0.91.
So I hit a wrong button.
Two decimals there.
Let's see what I did here. 7. Oh, I put in the wrong mu0. That's important. 3.69, 0.62, 90. The rest is right. Okay. Yeah, I messed up. All right, let me try again. So this time I got, negative 0.92. Yeah, I'm with you now. Negative 0.92. The p-value, 0.361. Okay. We good to there now? So now can we draw the conclusions? So is that p-value low or high? Yeah. The p is high. So if the p is low, the null must go. So the HO must stay this time, huh? The P is high, the HO stays. So I'm going to circle HO. So notice how I always end up circling whichever one wins the court case. So we did not reject. We failed to reject. We're keeping HO. We're keeping the claim. Is there strong evidence or weak?
Weak.
There's weak evidence. So even though we are going with the claim, evidence was still weak. The only reason we're going with the claim is because it was assumed to be true. So I want you to know that. It would be wrong if you did a study like this and you wrote up a note to, or you presented before a group of colleagues and said, yeah, we're going with the claim because the evidence was strong. No, that's not what happened here. We're going with the claim, yes. But it's because we assumed the claim was true. The claim ended up being the assumption of innocence, right? So there was only weak evidence. So if this is really important to your company, you might want to restructure the way you test it, because we still haven't got strong confidence the claim is right. We just don't have strong confidence it's wrong. See the difference between those two? If you're betting the bottom line of the whole company on it, you might want to do it a little different and get strong evidence, right? We don't have strong evidence here for the claim. So state the final conclusion that addresses the original claim. Do we reject or fail to reject? The HO. Yeah, fail to reject. We're keeping the HO, huh? We're not rejecting it. There is, to conclude that the original claim is equal to 3.75, there is, oh, right, yeah, so it's weak evidence. So there's insufficient, not sufficient. So there's weak evidence, there's not sufficient evidence to conclude that the original claim is not correct.
Not sufficient evidence.
I know, that's so confusing, huh? It's a double negative. Is that confusing?
Yeah.
Let me help you with that. Everybody see here what happened? So first off, remember there's weak evidence.
For it to be that.
Weak evidence. Whenever you do HO, that's always because evidence was weak. That's why we're saying not sufficient. But not sufficient for what? Not sufficient to reject the claim, huh? Right? You getting the idea? It's always weak if you're staying with HO, and if you had strong, you can go with H1. Whether that's the claim or not. So there's not enough evidence to reject this claim. So there's not enough evidence to conclude that the original claim is wrong, is not correct. I'm sorry, I know it's confusing. How about if you say it this way? In a court of law, if you end up with innocent, there's not enough evidence to prove that the original claim of innocence is not correct. That's what we basically said. Is that double negative confusing?
Yes.
I know it is confusing. I can say it a few more times. I can just tell you my experience. To taking math and science classes, I was confused a million times. and I would take the stuff home, and I would say it to myself again and again and again, and I'd think on it and redo the problems, and eventually I'd go, oh. So this may be one of those moments. I rarely grabbed everything in class. So I'll try to say again, but this is a deeper concept. Got to spend some time letting it sink in. So there's not enough evidence to reject the claim, is there? So there's not enough evidence to say the claim is not correct. We assumed the claim. And there wasn't enough evidence to get rid of that. You always need strong evidence to go to H1. So there was not enough evidence to claim that the claim is not correct. So it's weak evidence. All right, well, I'll leave it at that. You keep thinking on that. Don't know what else to say. Sorry, I've out of ideas, basically. It's just, I could just say the same thing again. I don't know, that's not very helpful. But just think about, the main thing, if you're getting confused by that, keep thinking on the innocent guilty thing. That's what we're doing. That's totally what we're doing here. So you're always assuming the HO, right? And only if evidence is strong are you able to say no to the HO. We were not able to here. We failed to reject the HO. Evidence was weak. So there was not enough evidence to say this is not right. It is not correct. There was not enough evidence to say this is not right. Like saying there's not enough evidence to say he's not innocent. When you let somebody go, like I was on that one rape trial and we let that guy go because everybody was drunk, so it wasn't clear exactly what happened. I have my suspicions, but it wasn't 100% clear because there was too much confusion. So it was not enough evidence to say he was not innocent. Right? Not enough evidence to say that the HO is not correct. Not for not. That's what we're saying. All right, I'll quit beating that drum. I don't think I'm helping anymore. All right, so on to number 5. All right, test of the effectiveness of garlic for lowering cholesterol. Is that true? I love garlic. I should eat more of it. For me, can I just be personal in my marriage? It's a simple choice. My wife says when I eat garlic, it comes out of my pores. So if I want to kiss my sweet wife, I don't have garlic. So it's a choice, Sometimes you weigh it out. And I usually prefer to kiss my sweet wife. So I limit the garlic. But anyway, garlic lowering cholesterol. So 64 subjects were treated with raw garlic. I'm not sure about that. That's a little dramatic. Cholesterol levels were measured before and after treatment. The changes before, minus, after, in their levels of LDL cholesterol in milligrams per DL, whatever that is, have a mean of 0.9, standard deviation 22.8. Use the 0.01 significance level to test the claim that with garlic treatment, the mean change in LDL is greater than 0. All right, let's write out the claim. So the claim. So what is our claim? Okay, where does it say that we're... Oh, here it is. Test the claim that the mean is greater than 0. Is that good? So I'm going to write mean greater than 0. Good so far? All right, and then we go to the HO, and we go to the H1. All right, let me let you take it from there. What we're doing here. So HO is always what? Always equal. Always equal. And so what's the H1 going to be? Greater, right? Because, and where's the claim go? See, it's the exact match with the claim. See how I always track through that? All right, then let's go. And then you got to put stuff in your calculator again. So we're going to the t-test again. And the mu 0 is just 0, right? The x bar they're giving me somewhere. Mean, there it is, 0.9. The standard deviation is 22.8.
And a 6 before.
So this is 0.9, 2.8. What's the N?
64.
64, thank you. N is 64. I don't even see it. Where are you seeing that, Val? I'm sure you're right. I just
First line,
want to underline it.
first line.
Oh, I can't see it. My iPad goes over that little part there. Is that it? Oh yeah, thanks. Okay, 64, and now what? And then what is it? Ours is greater, huh? So we circle the greater than, and then calculate. So here's the numbers I'm getting. I'm getting a test statistic, 0.32, and a p-value. P-value is what we always use. 0.3761 is to round to 3 places. So 377. 0.377. Okay. So now, so I think maybe it'll help if I just write this out every time. If the P is low, HO must go. So is the P low?
No.
No. So I'll write not low, not go. How about? Yeah, how about that? How about I just write nots next to it? This one's not low, right? This P is not low. So if the P is not low, the HO is not going to go. So HO is not going to go away. So the HO is going to stay. We're concluding HO, huh? Which always means what? Weak or strong? Weak. Always weak, because that's the assumption of innocence. That's weak. All right, so we reject or fail to reject?
Failed to reject.
Fail to reject. We're keeping the HO. There is what?
Not sufficient.
Not weak, so not sufficient. Not sufficient evidence to conclude that the mean of population of changes. So basically, well, oh, I'm confused myself. What are we saying? There is not sufficient evidence to conclude that the mean of the population. What was the claim? They're getting to the claim here. What was the claim?
Greater than.
But we didn't go with that, did we?
Right.
There wasn't enough evidence. We stayed with HO. There wasn't enough evidence to say it was greater than 0. So greater. Because that's what we were trying to say, but there wasn't enough evidence to say that. Is that good? Is that making sense? There's not sufficient evidence to conclude that it's greater than 0. We didn't go with the claim. He's getting a little better?
Yeah.
Questions I can answer. The next one we're going to go to data. Putting in our own data, which is not hard. Just like last time, put them in L1. Might be easier in some ways. Is that okay? Questions on that one then? All right. Here we go. Listed below are the lead concentrations in whatever that is, measured in different traditional medicines. Use only lead. Sorry, I'm reading badly. I am a math teacher, not an English teacher, and I'm showing that tonight. I wrote it's lead. I read lead. No wonder that sentence wasn't making any sense. The lead concentrations, the lead concentrations. That always confuses me. Did you spell lead LED with the, when it's got the A? I guess that's the metal, huh? All right. Use a 0.10 significance level to test the claim that the mean lead concentration is less than 17. All right. So, does this, how do you pronounce that? That's lead. How do you pronounce this? So how do you, what if you say, I led the race? Isn't that right? What if you said, he ate lead? But, no, this isn't right, is it? What are you guys letting me do this for? That's craziness. Yeah. I'm just having fun. I'm not an English teacher, and we can all see why now. Yeah, it is, huh? Homophone? Oh, yeah. Yeah. Am I saying it wrong? What's funny here, here's what cracks me up. That this is lead, but this is lead. That same word can be pronounced differently depending on what you mean by it, right? It's lead if you mean the metal, but if you're saying he's going to lead the race, then it's lead. All right. Anyway,
What if you drop the lead or drop the lead?
Yeah, right. Who knows which one you mean, huh? That's why I didn't major in English. All right. So type these into L1. Put these into L1 in your calculator. Hit stat. Wait, is that where it is? Yeah, stat. Edit. Yeah, that's it. Edit. Yeah, stat. So stat. Edit. Go up to L1. Clear whatever you got in there. Bless you. And then put those numbers right down the list.
Thank you.
I think it was the English stuff I was doing really mine. I was allergic too. I used to always write English papers when I took those classes, and I would always get B's and C's, and I would always say, why? What did I miss? Show me where I lost points. I didn't. I wasn't really ornery. But I always felt like, what was wrong there? Did I do something incorrect?
Was it your spelling?
Yeah, maybe it was my spelling and punctuation, yes. All right, so put those into L1. Once you've got them in, it's got it stored. We got to write out the claim and all that stuff, but then, so what is the claim here? The claim is, right there.
Less than.
Yeah, mu less than 17, yeah. Less than, so we'll write the HO, the H1. What is HO always? Equals. We always keep the same number, 17. So the claim then must be right there at H1, huh?
Which is strong evidence.
And so now let's go to our calculator. Then you go stat, go over to tests. So once you've got it put into L1, go down to T test. And then this time you're going to select the input from data. So input, just like we did in the last section. So this time data, because you're taking the L1 data. And so then it'll say mu 0. Mu 0, what's mu 0? That's the 17, because that's always by the H0, huh? So mu 0. The list, that's going to probably already have L1, just leave it. Frequency, you don't need to mess with that. And then, yeah, go to the less than, huh? Go down and choose the less than and calculate. And I'm getting T equals, if I didn't do anything wrong, 6.28. Y'all getting that? Anybody getting that?
Is it negative 1.93?
Oh, did I mess up?
Yep.
Looks like I did. I'm the teacher. I just keep messing up here. Minus 1.93. I told you. There it is. All right. 0.043. Yeah, there it is. All right, I had the wrong thing entered. Okay, so there's that. 0.043. So for our P. All right, so what's our conclusion? Let me write the sentence out that we always use. If the P is low, the HO must go. So is the P low?
Yeah.
Yeah, that's under 0.05. So the P is low, the null's going to go. So that means cross off the null, keep the H1, huh?
0.042.
Is that good?
0.042.
So I got 0.0427, right? So 0.043, round to 3 places. All right, so we're keeping the H1. We're keeping the H1. We're keeping the claim. Is there strong or weak evidence?
Strong.
Yeah, because H1 is always strong. Always strong. Whether the claim's there or not. Strong. So what do we do? Let's go down here. What do we do with HO?
It's still to reject.
Well, we rejected, huh?
Not rejected.
Yeah, we rejected the null. Reject the null.
So sufficient.
So there's enough evidence. There's strong, sufficient evidence to conclude that the mean lead concentrations is indeed less, right? We conclude the claim less than 17. there's some lead, low amount of lead, which is good.
Yeah, but we got that stuff down here, it's different.
Questions I can answer on that one? Is that good? Looks like you're all off and running, so I assume that's good.
Is frequency just one?
Yeah, just leave that one. Yeah, that just means those data numbers. Yeah, just leave that at one. We good? Questions on that one? More of the same. Got data. See if you can grab the claim. Wherever that is.
It was 4, so low, reject the whole.
Check that out. Okay, that's another setting, yeah.
The whole. Sufficient evidence.
I don't see a claim. Where's the claim? Oh, there it is, right in the middle. Okay. Test the claim. There it is. Test the claim. Mean equal to 60. So claim mean equal to 60. So try that one. All right, HO. So mu equals 60, and that is the claim, huh? So what do we do for H1? Not equal. Not equal, right? Because there's no greater than, less than here anywhere. The claim is the equals. Okay, so put the stuff in your calculator. So we put this, so all this goes in L1, right? You hit stat, you put all this in list 1 by hitting stat and edit in L1. Stat, edit L1, put all that stuff in L1, and then you go stat and t-test, and then the mu0 is 60. What do they have us do? Mu0 is 60. The list is L1. And we choose the not. Did you remember to do the not equals? Got to choose the not equals. And then calculate. And I'm getting t equals 2.35, yeah. 2.35. And the p-value 0.034. All right, so let me write the statement again. If the p is low, the null must go. So is the p low?
Yes.
Well, is it lower than 0.01?
Oh, good question. I didn't notice that, Mai. Thank you. I was about to say yes. Yeah, it's the comparison is 0.1. They gave us a really strict one this time. So it's...
So the last one was that too. So then...
Was it? No, I don't think it was.
Yeah.
The 0.10.
Oh, 0.10.
That was actually higher. Yeah. I know. They're kind of playing games with the significance level. Yeah, that was a 10. This one's a super tight test. It's 0.1. Is it lower than 0.01? No. It's not lower than. They wanted strong data beyond a 1%, below a 1% chance of luck is what they're saying. The significance level is the chance of luck. They want there to be almost no chance of luck on this one. So is it lower than 0.01? No. So the P is not low enough. So the HO must not go. So we keep HO, don't we? We keep HO. It's not low. So the null does not go. We keep HO. Is that strong or weak evidence?
Weak.
That's weak. Whenever you're doing the HO, it's always weak evidence. So you're keeping the original assumption of innocence. All right, here we go. Do we reject or fail to reject HO? Fail to reject. We didn't reject it. We kept it, huh?
Right.
Failed to reject. Is there sufficient or not sufficient? There's weak. That's not sufficient. It's weak. Evidence to conclude that the original claim that the mean of the population is what?
Is correct.
That's good.
I'm not sure. I got to think about it.
Original claim is.
There's not sufficient. So think about what we did. We stayed with the HO. So there was weak evidence. There was not enough evidence to reject this. So there was not enough evidence, not sufficient, not enough evidence to conclude that the original claim that the mean population was 6. Oh yeah, here this is just original claim. Yeah, maybe I shouldn't be so confusing. Right here, they're just saying, what is the original claim? That the mean of the population is 60 seconds.
Is correct.
Is not correct. Right? There was not enough evidence to say the claim was wrong.
Probably the double one again.
It's the double one again. Is that confusing? So think about this. If we said correct, if we said is correct, we would be saying the original, there was not enough evidence.
But it's still correct. That's what you're saying, right?
There was not enough evidence to say it's not correct. Yeah. Right. That's what we conclude. There was not enough evidence to reject the claim.
Are you gonna put those questions on there in the test?
I'm sorry, yes. The homework is fair game for the test. I know it's not easy. Spend some time. These things come over time. So that, I can try to say it again. So again, we were not able to reject the claim, were we? The claim was the original, and we were not able to reject it. So there was not enough evidence to say the claim is not correct. There was not enough evidence to say the claim is not correct. That's what we concluded there. How are we doing on that? Right? I mean, it wouldn't be right to say is correct there, right? You know, to say there's not enough evidence to say the claim is correct. Well, we ended up with the claim. So there was not enough evidence to say it was wrong. So we stuck with it. Right? The HO is what you start with. There was not enough evidence to say that the original claim is not correct. It appears, or does not appear, that as a group the students are reasonably good at estimating 1 minute. Does it appear or does it not? Well, what did we end up concluding? They were trying to estimate 1 minute. We concluded that it was equal to 60. We concluded they were pretty close to on 60. So it appears that as a group, the students are reasonably good at estimating 1 minute. Right? We stayed with 60, rather than saying they weren't getting 60 seconds.
The week. That was included.
Yeah, that's what's weird, huh? It's weird when we go with the weak conclusion. But it's just like a court of law. Think about what happens in a court of law. You don't conclude that. I always think it's funny. Remember those old lawyer shows, Matlock, or those old ones, yeah. Perry Mason. Go back. That was funny. Think about what those. Maybe that'd be helpful. Think about what they did. If you've ever seen any of those old lawyers, let's do one. Here we go. Assume that a simple random sample has been selected. Normal student population. Test. Identify the null. Blah blah. Safety Administration conducted a crash test of child booster seats for cars. Listed below are the results from those tests, with the measurements given in HIC. Do you know HIC? HIC? Standard Head Injury Condition Units. Never heard of it before today. Myself. All right. The safety requirement is that the HIC measurement should be less than 1,000 HIC. Use the point level to test the claim at the sample with mean less than 1,000 HIC. So the claim, less than 1,000. Head injury condition units. All right. So what's HO? HO's always equal. So the claim is the H1 this time, isn't it? Put the stuff in your calculator. Put this in L1. Let's do the test. So we go to the t-test, and we have the mu0 is 1,000. We're going to do from data, right? From data, it's 1,000. And we're doing the less than. And so I hit the button. I got, what did I get? I got t equals, hopefully I didn't mess up, minus 3.29.
Yes.
Good. Okay, and the p-value, 0.011.
0108.
Right, so it rounds to 011?
No,
It says
it's S for 4.
Oh, thank you. All of a sudden they're changing their desires. 0108? All right, so let me write the statement that we live and die by here. If the P is low, the HO must go. So is the P low?
Yes.
Yeah, that's below. We're testing at the 0.05 level, huh? So that's lower than 0.05. So the P is low and the null must go. Bye-bye, null. We're keeping the H1. Strong evidence or weak? Strong. H1's always strong. All right, final conclusion. What do we do with the null? We reject it, right? We said bye-bye to the null. Right there, I rejected it. There's sufficient, there's strong evidence on this one. To conclude, whatever that says down there, which I can't see. Is it even on the screen? I don't even know what that says. What does that say? What do the results suggest about the child booster seeds? What did we conclude?
That's
Less than 1,000. So that's good. We conclude they're less than 1,000, which is what they said was for safe. So whatever it is, less than 1,000, they are safe.
And one of the seats higher than 1,000.
Oh, they did?
Yeah.
Where's it say?
It's on the list.
Think measurement should be right. No, it says right here. Should be less than 1,000. The safety requirement.
The answer says that it's less than 1,000, but there's one that has over. So that's it.
So what, state the final conclusion we did. What do the results suggest about it? There is strong evidence that the mean is less than 1,000. That's true. But one of the boosters, oh yeah, one of them was greater than 1,000. But there's strong evidence that the real average is less.